Well, Gavin, thank you so much for helping my project. Could you say a little bit about yourself?
Yeah, certainly. So my name's Gavin Tolometti. I'm a fifth year PhD student at Western University in London, Ontario, Canada. And part of my work is to use radar to understand how lava flows are emplaced on planetary bodies, mainly Earth, the Moon, and a little bit on Mars. And I'm originally from the United Kingdom.
And what got you interested in the moon?
Um, I would say it definitely took until maybe the end of my undergraduate year where I attended one course where there's a little bit of planetary science, and the moon was partially involved in that course. So that's when I was first exposed to more of the science about the moon, but it wasn't until I started my master's and now my PhD at Western University, I started to take more courses that involved understanding the history of the moon, the types of lunar missions that have happened in the past and are going to happen, and getting involved in research projects that involve trying to address high priority science questions for the moon.
And all of your radar research of lava tubes on the moon, is that from orbiting spacecraft, or are you able to get some information even from sending radar as far away as Earth?
Yes, it's a combination of two. I don't specifically focus on lava tubes, but some of them could be, but it's hard to tell looking at some of the data. But I use two types of radar data. One from the miniature radio frequency instrument on the Lunar Reconnaissance Orbiter. Still orbiting the moon and collecting new information. And before it did unfortunately collapse, we used Arecibo radar data from the Arecibo Observatory in Puerto Rico, and that's the ground-based radar we're able to get. But we can only get about 60% coverage of the moon since it can only see the near side. But the mini RF, that's what the other one's short for, is able to get radar data on the far side when it's able to orbit over there.
And I guess in terms of going through the analysis of the data you get back, what does that look like?
It would depend. It will look like kind of like a pixelated image, but it can, depending on its resolution, look like an actual image. But it's able to see what optical light or visible light is not able to see. So I guess the best example I can think of is like you can picture a black and white image where the lava flows will, if they're there, will appear quite bright, which usually tells us like those are very radar bright, which means they're very rough because they're scattering so many radar signals. And then you get patches that are probably very dark, and they're probably going to be like just regolith cover or soil or dust if it's Mars, or just a flat or smooth bearing rock exposure. So that's probably the best way I could probably describe the radar data without getting to show a visual representation. So it's like a pixelated black. It can be colorized, but usually it's a black and white image.
Ah, I see where my confusion was. You said lava flows instead of lava tubes. So I guess my mind just inserted tubes instead of flows on that. But my understanding, and I'd like to see if this is correct or not, is that there are more pronounced lava flows on the Earth-facing side of the moon with like the Mara or Mare, I guess, than there are on the far side, which doesn't appear to have those same types of features. Is that correct?
Yes, yeah, the near side of the moon does have a lot more of the mare lava, and a lot of the hypothesis for that is because they think because the far side, the crust on the far side of the moon is a lot thicker, so it would have been harder for volcanic eruptions to occur because they'd have to have rise and intrude through a lot more crustal material. But on the near side, it's a lot thinner, so it was easier for a lot of lava to erupt. And there's also a lot more, it's more younger impact basins, those giant circular features you probably see on the moon, like the really big ones. So they probably created temporary weak spots that would have allowed lava to erupt. So there's a lot of reasons why this could be, but I think the main one is because the crust is thinner on the near side and it's thicker on the far side.
Any thoughts about why that might be?
Um, I'm not really too familiar with that side of lunar science. A lot of it could be either due to just how a lot of it could be due to impact basin formation. That depends how it's been how the crust has probably been modified and distributed when the moon was still young. and some of it could be just how the moon potentially cooled. There's a lot of models that try to explain why one side's very got thin crust and one side's got very thick crust because it's not active like Earth is with plate tectonics. So I can't really say exactly for sure, but I do think that impact cratering probably played a role, but there's not enough evidence to really support that could have been the only reason why this reason is thin on the near side and thick on the far side.
And um, I guess you probably knew early on that we were planning to send NASA astronauts back to the moon in 2024. Do you remember how you found out?
How did I find out? I think it was through my I heard a couple of I remember when it was like very on like few years ago when it was probably being hinted on in the news that NASA's planning to try and do something like this, but nothing was confirmed. But I think I found out when I think when a year or so after I started my master's in 2016, 2017, I think it was like a lab group meeting we were having, and my supervisor brought up the news. I think it was, I can't remember if it was before it was publicly announced or something. I think we weren't allowed to say anything until it was put on the news. But I think he said that, oh, I think it's been NASA's pretty much confirmed that they're going to send the next man and first woman onto the far side of the moon as the next stages towards deep space exploration. So I think believe it has been a while since I thought about it, but I think that is how I found out.
And what was your reaction?
I was quite happy. I mean, it's been a while. I mean, we haven't had any major lunar exploration since the Apollo era. I mean, we've sent orbiters and the occasional lander. The Soviets sent robotic platforms after NASA stopped the Apollo program, but since then we've not really had any major lunar missions because everyone shifted towards Mars, sending rovers over to the red planet. So we haven't had the chance to think how, when we'll be able to go forward to the moon and forward when it comes to one addressing questions, science questions that were brought up during the Apollo era or weren't answered because we didn't have the right samples. And now it's going to be turning more into the testing grounds for long-term exploration for humans and robotics in deep space exploration, and for testing new equipment and strategies for when astronauts would eventually get sent to Mars. Because the moon is the perfect training ground because it's only 2 to 3 days away, other than Mars, which at best is 6 months away. And so if something does go wrong when you're testing all this different technology, you're at least very close to home. Instead of if something goes wrong on Mars without any tests, then you are in a bit of a difficult situation because there's not really much you can do at that point.
Yeah, I know. It's amazing. I've been reading some books from like flight controllers and from people involved in the space program, and the thing that continuously is highlighted for me is how dependent the astronauts are on like an entire team of support people on Earth. That they're not actually debugging and troubleshooting and resolving issues. They're more like the eyes, ears, and hands for a whole army of engineers on the ground. And as this group of people moves further away from the Earth, and the communication becomes more constrained, it's unclear to me exactly how they'll be able to support themselves. So, I mean, obviously, the more we could test that out before losing some astronauts would be a good idea.
Yeah, it would definitely be a good idea and save a lot of lives and probably a lot of money.
Right, and a lot of time too. And I don't mean
Mm,
like hours, but kind of decades as people go, is it worth it? And why are we doing that?
yeah.
Um, I guess as a geologist, I mean, would that be correct to call you a geologist?
Um, I would say I would still consider myself a geologist in training. I think until probably I finish my PhD, I wouldn't want to call myself a geologist yet, but I'm close. I'm getting there.
Okay. But okay, so as a geologist in training, what would you hope to have the astronauts on the ground provide to you in terms of information that you're not able to get through, orbital observations?
Well, the big one in lunar exploration is confirming how much and how much and how deep water ice and other in situ resources are on the moon, because orbital data is able to tell us that they can detect uh, spectra or like signatures of water-bearing minerals and hydroxyl minerals, which is just the O. It's a single oxygen hydrogen ion attached to a mineral, and hydrogen as well, and many other minerals such as titanium and elements such as titanium and helium. So orbital data is good for detecting large quantities, but it can never. It's really, we still don't have the best ways of saying exactly how much is actually there and how deep it is beneath the regolith. There's a lot of numbers get thrown out, like saying like so many metric tons. There's a lot of skepticism from that because that's a huge assumption basing off remote sensing data unless you've got a lot of information to support that. But that's so astronauts one would be able to confirm that in some cases robotic platforms would be better to do that, because a lot of the looking for water ice and volatiles are in what we call permanently shadowed regions on the moon, so where they barely or get little to no sunlight exposure at all. So temperatures could be below negative 200 degrees. So unless we have like super advanced spacesuits, which I don't think we're going to have for a while, we can't physically enter those regions. But robotic platforms can, and they can prospect, do some drilling, collect samples, and bring them back, and then the astronauts can collect those samples and return them back to Earth for more detailed analysis. I think that's probably going to be the best type of samples that we can bring back. In terms of other science goals, we don't really have any samples from the far side in general. So even if it's the same type of samples that we collected on the near side, they might contain new information in their composition, uh, recording paleomagnetic signatures, which is just a rock's way. Well, minerals are able to record the magnetic direction and orientation of the moon in its past, as long as it's not been modified so much. And in general, we might find new samples that we've never found before because the far side's unexplored. So remote sensing data can show us similarities between both sides, but there's also differences. So we'd want to be able to, one, compare both sides, and one, to be able to what we'd call ground truth the remote sensing data. That we want to see how accurate our orbitals actually are at saying this, what we're reading here is potentially this sample. Once we get down there, we'll be able to confirm, like, is it that what sample is what it's trying to recommend, or is something completely different? If it's the same, great. It's doing it, it's recognizing it well. If it's not, then you can then calibrate the orbiters to perform better science in the future. So I think I rambled on a little bit there, but I think that's kind of what I'd say what we'd want to return.
Yeah, and you mentioned, that these permanently shadowed areas are negative 200 degrees Celsius, and that sending a suited human in there definitely would be maybe contraindicated. But I mean, do we even have machines that can operate at that temperature?
Well, there's been a lot of testing. The closest one I can think of, it would be the Viper mission, which is going to be landing, I believe it's 2023. I recently heard. I might have to quickly confirm that. So, but I believe it's that is a rover that's going to have a drill that will, I think it goes about a meter or so into the regolith to try and find water ice material, take a sample, and bring it and return it to Earth for more detailed analysis, because that's going to be able to confirm whether we can how much water ice is actually present. So yeah, late 2023 is when it's going to be launched. It's a NASA's Commercial Lunar Payload Services program. So it's going to arrive before the astronauts would on the far side of the moon, because it would be able to get into these darker, permanently shadowed regions and collect samples, as well as collect samples outside, because they won't be able to compare. Actually, is there actually anything beneath the regolith where it's illuminated a lot by the sun?
Yeah, and you bring up the Commercial Lunar Payload Services Program, which I'm a big fan of. The idea of having these, I mean, originally 15 companies competing for 2 work orders a year for a decade to actually deliver NASA instruments to the moon, as well as anything else, is pretty neat. The company that's delivering Viper in 2023 is Astrobotics in Pittsburgh, and they're also sending a probe this year to the moon. It won't have a rover on it. But I was wondering if there's any type of um, science instrument on that are the other mission that's going to the moon this year from Intuitive Machines based here in Houston, um, that would collect data that would be useful in the work you do.
Um, I can't remember what the instruments were on those payloads, so I don't know if I could answer that question confidently. I'd have to.
I know that they probably have some instruments to characterize dust, and that I know that's a big concern with equipment and with the humans is how to mitigate the electrically charged dust that just kind of accumulates on your suit and gets into your vehicle, and what to do about that. But yeah, I don't remember much about the instruments there. I do know, like on the Astrobotic mission, they were doing a special promotion of DHL, the package delivery firm, where you could send like what they call a moon box to the moon. And so I actually had a micro SD card that I put in the first year's worth of these interviews on that's going to the moon. So not really a scientific thing, and really questionable value, but kind of need to at least have some type of participation in that project.
Yeah, no, definitely. I think with the dust studies, and for me, it won't help my type of work at all, but it is an important thing to study because, as you mentioned, it can do a lot of damage to instrumentation if they're not careful, and also to for astronauts when they go onto the surface. They realized during the Apollo days that that they realized the dust is actually very sharp and electrically charged, so it sticks to the suits very easily, and it's very hard to get off. So it's then testing like, okay, what can we do to maybe mitigate this problem? Other ways that we can have astronauts maybe not bring suits inside habitat chambers, because then you've got to deal with getting the regolith out, and then if it gets into, let's say, an air filter on that habitat, then you probably have a really big problem. What if it punctures the suit? Since it is sharp, it's going to be like sharp shards of glass, so it's going to be, you need to make sure your suit's tough enough to withstand that material. And same with like wiring on in instruments and probably solar panels. If it has a huge damage to those material, that equipment, you're going to run into a bit of a problem when it comes to performing lunar exploration, not just for the commercial side, but also for like the scientific side.
Yeah, absolutely. Coming back to Viper and that sort of core sample from that negative 200 degrees Celsius area, um, I mean, how cool do we have to keep that sample to be able to keep it intact, to actually be able to study it? I mean, it's like, I mean, aren't there some things that freeze at really low temperatures that we might lose as it gets heated up?
I believe I think preferably, like, if it was possible, you'd want to keep it at the temperature that you sampled it at, because then it's like, all right, we collected it at this temperature, so we know it's going to be stable if we keep it at this temperature. But I'd say when it comes to storing it, I'm not entirely sure about what's been what the mission would use. I'm not very familiar with the sampling chambers that they probably use. I would imagine they'd want to keep it as cold as possible, probably enough that so water doesn't evaporate or any of the other volatiles evaporate. So I guess it will depend on. I can't give a number, but I would say it would depend on whichever volatile they're trying to collect has the lower has the lowest evaporation point, uh, boiling point at that point. Because if they keep it as low as that, then anything higher is definitely going to stay frozen.
What do you think about the possibility of it actually containing some prehistoric life samples? I'm thinking, that asteroid that hit the Earth that created the class, the that blocked out the sun that killed the dinosaurs and the early
Mhm.
life. I wonder if it was able to actually launch some things into orbit and maybe even to the vicinity of the moon, and maybe some of that material actually fell into these permanently shadowed places and could be preserved in a really interesting. I mean, of course, I mean, I went through so much trauma, it's like once you've done all that, I'm not sure what you're preserving, but microscopic life might have been kind of protected somehow through that whole process.
Oh, sorry. Yeah, I just lost you for a second.
Yeah.
But to
I
answer,
mean, so it's like really awesome. I mean, people think, wow, water ice, but maybe there's a lot more there than just water ice.
um, I mean, I'm actually not so. I've never really heard of that. I mean, I've heard of the theory that if they did a large impact, it did hit Earth. There's a possibility some of that material did hit the moon, but I never really thought about whether it would have preserved biosignatures. Personally, I think it'd be extremely difficult for that to happen. Mainly because like usually when impact events, it usually eradicates most not just the structure of pre-existing rocks, depending on how much shock they've experienced or how much excess heat they've been experiencing, but also that when it comes to like organic material, it's quite easy to vaporize it. So the chances of it being preserved and then landing on the moon is very unlikely. Plus, even if it did, then you have to hope that it's able to withstand the constant exposure of cosmic and solar radiation on top of the impact gardening on the moon, which is just micrometeorites that constantly hitting the surface. It's why we see so many craters. So I want to say I don't think it would be preserved there. I mean, they'd have to find hard evidence if they ever to bring back a sample to say that this is what this structure that we're seeing inside the rock is actually preservation preserved remnants of a early microbe that was once existed on Earth 65 to 66 million years ago. So I think it sounds a little bit skeptical coming from me, but I just think it would be very tricky, and I'm not entirely sure whether it'd be possible. But again, I don't. This is the first time I'm hearing of it, so I'd probably have to look into more papers to confirm what I'm saying. But I'm saying if you are interested to know more, I'd say if you definitely look for some scientific journals to look into this, see what it's like, if this material can be preserved from large impact events. I'd say definitely go for it because they'll definitely have a lot more information than I can probably provide right now.
Yeah, no, that makes 100% sense, and I share your skepticism, but also one of the benefits of exploring the moon is to find out the things that we don't even know we don't even know.
Yeah.
So I'm always a little concerned about going into an unknown situation with the assumption of known knowns. I mean, you have to make some assumptions, but you always have to put a little question mark beside them, and be willing to kind of change them on a dime
Mhm.
when you start getting data. Um, so I mean, I think exploring the moon is beneficial in and of itself. Like just as people might appreciate art or pure mathematics or some type of TV show or playing some type of video game or sports. I mean, nobody really questions the value of those things in terms of what kind of impact they have. I mean, sometimes that comes out. So but whenever it comes to expensive scientific exploration and development goals that need to be supported by a wider community of people and resources who may not share that same value system that I have and I presume you have as well because of your field of study. Um, uh, I mean, how do you have those conversations to sort of try to make it meaningful to this broader audience?
I think for me, it's that if I know the science question is very specific, like, oh, I want to study this type of mineral to tell us about using this specific technique to tell us about this specific property of the moon. Majority of the time, unless you're really into the moon and the science, you're not really going to be that interested in that type of study. So what I normally do is if I talk about lunar exploration, I will talk about what we can actually gain from these missions and studies, not just the aspect of exploring and being curious and learning new things, but it's also about testing new technology and actually bringing some of this new technology, which is known as spin-off technologies. So, and it's quite surprising when you look if you think about a lot of everyday items that we rely on only were only designed because of either a company that was funded by NASA to develop something for them for space, which then they marketed for everyone on Earth, or was originally designed for space exploration, but then someone wanted to convert it to then be used every day on Earth. A lot of the common ones is solar panels. It was originally used to power satellites in the International Space Station, then came to being used as a renewable source of energy or on Earth. Another one is GPS is the common one. If it wasn't for satellites, you wouldn't be able to use Google Maps at all, and to use internet in a lot of locations, especially if you're not near a tower. And I think one of my other common fun ones is memory foam for your mattress. That was originally designed. NASA funded a company to make it more comfortable for crash test pilots, and then came memory foam from there. Another one is that everyone takes cameras on their smartphones. That came from a chip that was miniaturized from a satellite mission. So that's why I like to say the phrase "selfies came from space," because it is that camera, that chip in your camera is because of a mission that launched a satellite. And for the last one, I think, which is probably one of the coolest ones I can think of, is the Canadarm that's on the International Space Station. The medical industry a company miniaturized that for the medical industry to help surgeons perform brain surgery, which is now called the neuroarm. So it's all these different things that we can gain. There's so many more, but it's just that's usually how I like to engage with the public when it comes to lunar exploration or any type of space exploration in general. Like that's if they're not interested in the specific topic, they're going to be interested in what actually comes from space exploration, how money's not being wasted. And even if we don't get anything from it, the money's not really wasted. It does go back into the economy. It's just not the traditional way of going back into the economy. It still hires all of these engineers, scientists, and administrators, and and all these companies that come in to help design things. They gain profit, then it goes back into the economy from there. So, but I don't know that side very well. I'm not an economist, so I wouldn't quote me too much on that.
I didn't know about the Canada arm and the neural arm. I've had to write that down and have to take a look at it some more. The spin-offs is definitely a common justification for the expenditures in space, but kind of on the other side of that, though, a counter argument is if your goal is to develop this technology, why not just try to develop that technology? Why do something um, some activity in the hopes that you have spin-offs as opposed to just thinking about what technology you need and making a direct line towards it.
I think some of it's just not really planned. It's just some of the technology just comes because of the mission. It was not like we're going to do this mission because we want to get this technology designed back on Earth. Sometimes it just happens. It's convenient, and usually when you're put in a scenario where you're having to design a mission that can survive the harsh conditions of space, it really pushes more of the innovation and creativity of humans. Because I think if you got the comfort of planet Earth, it's sometimes harder to really see some of the problems that you could actually then fix. So I think a lot of it comes from just I'm not going to say sheer luck because that's not really correct. I'm saying like some of it just comes from convenience coming from a mission, and others like since you're pushing more boundaries in space exploration, you then discover that you can actually find solutions to problems on Earth.
And maybe it's about the unconstrained thinking where you have to like go back to first principles and say what is it you're trying to accomplish, and you come up with new routes and stuff.
Mhm.
So, also the other side of it is in the Apollo program, oh, there's a lot of things we had no clue on how to do, and we were testing out a whole bunch of different things. And now that we figured out how to get stuff into orbit, we really haven't seen much development in terms of rocket technology, except for, if you look at SpaceX and Rocket Labs and these other um, uh, companies. Um, and NASA's really pushing using commercial off-the-shelf technology, which is almost the exact opposite of a spinoff. Uh, do you are you as hopeful that we're going to have a similar set of spinoffs with our return to the moon this time as we did last time, considering all that?
Oh, I definitely think so. I think we're going to see maybe not new technology, but improvements on technology that we use on Earth. I think a big ones will probably be like air filtration systems because they'll have to design very sophisticated ones if they do want long-term human what's the one thing? I say long-term human exploration and presence on the moon. That's the word. and other ones could be better relays of communication. They're starting to look more into optic lasers because they've always been using it, but I think they're trying to improve it even more. So it'll be faster telecommunication across the globe if it can be improved from the moon to Earth. And it could also see new material from the spacesuits since they're trying to make them more sturdier and more mobile. So we could see them used in more hazardous situations on Earth, or maybe for more emergency crews if they're having to deal with harsh environments. So I think there's definitely going to be new spin-up technology. A question of what? It's hard to say, but I'd be surprised if nothing involving air filtration will come out.
Well, and those are really kind of like near term, midterm type of repercussions of us returning to the moon and space exploration. But if you look at a longer term, 500 years ago, Christopher Columbus left Europe, came over to North America or to the Caribbean, and that began a period of sustained European migration into the Americas. And you see the development since then, and all this other good stuff. If we consider this point and look forward 500 years from now, where do you see humanity? What do you think it's going to be like?
In my more hopeful view, I do think that we will have a much larger presence in in space exploration, as well as probably a more sustainable way of living on Earth in terms of energy. I think by that point we will slowly start to realize, as I think there's the current and new generations keep moving forward, will realize there actually are better ways to one, live on our planet, and to live with our planet instead of using resources that we know are going to run out eventually, and it's just going to only help us in the short term, but in the long term we're going to be in a lot more trouble, especially in 500 years. I do think there'll be more. I A lot of people say that we'll probably have habitats on the moon and Mars by that point. I think definitely the moon I could see that happening. I maybe not a habitat, but there'll definitely be more established science posts, outposts, communication systems, and launch pads for deeper exploration. I would imagine we'd probably have a first established maybe I don't know if it would be either a colony on Mars, as everything that Elon Musk is saying. If he's serious about his goals, it's very possible. I will be until I actually see it happen. I don't know if he'll be able to beat his deadlines, but I could definitely see a major, maybe a research station, studying more of the Martian atmosphere, environment and atmosphere, and trying to learn more about how humans could sustainably live there. It'd probably be more like a huge research station and outpost more than a colony, I would imagine. But and I do think we so essentially, yeah, I think we'd have a much more sustained presence in space, and hopefully we have a much more control on our energy consumption on Earth.
That sounds like an awesome direction to go. But just touching on that one comment about Elon Musk and his seriousness for building a colony on Mars, is there anything that makes you think he's not serious about it?
I don't know if I don't think he's done anything that would make me not serious about it. I think the only thing I question is whether he's really thought of how he's going to, once he gets people there, how they're going to stay there long term. I mean, we see a lot of the work he's done when it comes to launch systems, but we've seen very little work on like habitat systems, testing, and how the humans would sustainably be there, because that's going to be the major thing. Getting there is one thing, but once you're there, you need to know exactly what to do. So I just don't know if they've thought that far through, or they're working with other companies that will design that or look into that for them, and they'll just worry more about getting the astronauts and colonists there. So I won't say I'm questioning whether he's serious. I'm more questioning of whether he's thought he's everything through, which I would hope that he has, but it's just I just haven't seen a lot to say that I'm 100% confident that they have thought everything through.
I'm 100% confident they have not. In
Yeah.
fact, he's kind of spoken about that and said that he really sees the need for other groups to really fill in those gaps and to
Mhm.
develop that. So uh, his point is, all that's pointless if we can't get there, and currently we can't. So I want to
Yeah.
focus on that. So,
Mhm.
talking about getting there, if it was safe and affordable, would you go to space?
See, I get asked this a few times, but if it was safe and affordable, I would go to space. As in, I'd love to go like an low Earth orbit, and maybe at most uh, a flyby around the moon. But I don't know if I'd want to physically land on one. I think for me, I've gotten so used to Earth. I think I prefer to be maybe in the room where we send people to the surfaces. But a low Earth orbit trip would be probably a bucket list if I could ever get there.
Talking about a trip around the moon, did you sign up for Dear Moon?
I have not, no, and I've been quite debating whether to do that or not.
Yeah, I believe that the initial application process actually closed, so it may not be um it may not be an option. So, yeah.
But
But hopefully it's not the last opportunity. I think this is the first of many. So
I have a feeling it probably will be the first of many, especially with more entrepreneurs and million and billionaires getting more invested in space exploration.
definitely. Well, Gavin, I really appreciate your time. Is there anything that you wanted to talk about that we didn't touch on?
Um, no, I don't really think so. I think we managed to cover quite a bit.
Well, I look forward to seeing more of your research, and I look forward to that day when you're like no longer a geologist in training, but you know, kind of like a geologist, where you feel comfortable calling yourself a geologist.
Yeah, I am looking forward to that as well. Thank you.
Okay, well, have a good rest of your day then.
You too. Thank you very much.
Bye bye.